Yeah, hi. Uh, I was thinking about something, and now I thought I'm gonna share this with you. It might seem and sound crazy, but let me explain. We are in Germany now, Andernach Geyser. About it's closed, a natural cold geyser, which is at the moment closed for whatever reason. Here we have some pictures, I guess. And it is a cold geyser. So, and it's at the Rhine River. Now let's go into the Alps. Follow the Rhine River, actually. And here's a river too, but it's another one. It's the Rhone, almost the same name. Rhone and Rhine. Okay, dropped pin. Was there a picture? There is. Thank you, John, for the picture. A little river in a valley somewhere in the Alps. Yeah, we don't do anything with those pictures. But I was watching at that yesterday. And I couldn't help it. This looked like really molten into place. Those sediments. And we have also water up there. And I wonder, is this a remnant of a geyser? Cold water geyser. I really wish I could use Google Earth for that. It would be easier to somehow zoom around, but it doesn't work somehow. I'm not able to drop pins or find the same places again. This has a similar feature somehow with this kind of elevation. You know, if you would watch it from the side, it would be like that. Even though we are on a hill, so this is elevated. And there's close to that is another one, but I showed you already once. There's a similar kind of scenery or geological features. So, and there has been glaciers. But there's Ice Cathedral also. I just noticed. Yeah, that's very impressive. So actually, if you watch at this picture, if you like get snow packed together, you would guess it stays white. But obviously, what are we looking at is blue. Which is really like ice. And what's the reason for there being a cave in the first place under a glacier if there is no heat coming from underneath, it won't create the cave. So now to the crazy part of that video. Let's take any hill we get here. Of course, you have to keep in mind, yeah, this doesn't work. So I probably have to draw. And I'm really bad in drawing. Especially this equipment, which is a phone. Now, this is the Earth's surface. And under the surface, there will be water somewhere. And under the water will be magma somewhere. And of course, this is really strongly simplified. There could be many layers. But let's keep it simple. And then we have the sky. This is now the sky, which has its own electrical potential. As does the ground. And if there is an electrical discharge, this is probably the better way of drawing a lightning bolt because it goes upwards and downwards. And if there is this kind of static electric field in somewhere, like in ancient times, when there were pole shifts and really different electromagnetic what is it? Environments. Okay. Now, there happens this kind of accretion towards that. And there are mountains. And of course, if you go more, like if you go further away, they decrease in height because the electrical potential decreases the further out you go. This is really simplified. So, what increases the conductivity in the whole thing? Water. So, probably in the middle of that, to some extent, like let's say if we would have atmospheric layers somewhere here, and that's the sky, the water will go up to some height and then it will probably, partially at least, transform into clouds. And there is wind and all these kind of things going on too, of course. So this is really simplified. So, if this current is strong enough and there is like this static electricity which doesn't heat things up like a lightning bolt does, and this lightning bolt is also just this kind of simplification of the electric currents which go between the ground and the sky. So, there is this little water vein where this mountain got created, and then the lightning bolt shuts off, and the connection from underneath here, like this gets warm because there is magma and there's water and the water goes up. And when everything is done, the mountain is ready. And we have, of course, still many of those water veins which originate somehow from the strongest impact of this whatever electronic discharge we had. So now, put this away. Let's go back to the Alps. What? Yeah, wrong button alarm. Now let's go to check out this one here. For example. This looks like you can see the sedimentary layers of those. And these look like molten rocks. Like when they have became into being, they have been molten. And there is yet another one with this thing in the middle, which is in a way elevated. It has this ring around it, like a caldera. So now the crazy part of my theory. Is it possible that wherever you find a glacier, let's find one glacier. Is it possible that we would have a spring of water here and here at the top, and there's just actual water, like it could be even a little bit warm every now and then. It depends on the electromagnetic condition of Earth. So is that the reason why we have glaciers in the first place? Because it's just a well which gets frozen over, and because of the pressure, there's just water coming and coming all the time, and it just gets frozen, and that's why they are somehow like flow really slowly downwards, because it keeps somehow the pressure of the water which is coming from the ground, which could be also somehow mineral rich. There could be sulfur in it and all these kind of things, what you find in usual geothermal activity, water and these kind of things. And it just creates those rivers of ice. And some of them have those caves, so which indicates there's heat coming from underneath, otherwise they wouldn't be caves. Some glaciers, they just somehow disappear. Could it be that the whole thing is just warming up from underground, and the water which is coming up from here is just too warm? It starts to melt the glacier from the root where it starts, or it just doesn't come anymore, the water. If there has been some earthquake somewhere deep underneath, it got stuck and there's no water anymore. And the heat is still rising, so it starts to melt. I don't know, this is just one idea what I had. I thought about this for some time, and now I just brought it out there. So are glaciers indicators of geothermal activity, or how to put it, water dynamic activity? Yeah, I leave it here. Thanks. Bye.